Hello, everyone. My name is Magali Cardenas, and I did my presentation on an article named Eye-Gaze Performance for Children with Severe Physical Impairments Using Gaze-Based Assistive Technology, a longitudinal study. So this article was about children with cerebral palsy that had severe motor impairment, and this was often associated with concomitant cognitive impairment and limited performance in their everyday activities. These children had no control over their body movements, and they also could not speak. The only thing they could voluntarily control were their eye movements. So they developed this assistive technology based on a computer controlled by their own eyes, and they named this gaze-based assistive technology. With this, children can communicate and perform a range of activities even if they have severe impairment. This study was a performance-based study that examined changes of eye gaze performance over time in children with severe physical impairments without any speaking ability using only gaze-based assistive technology. So my research question was, is gaze-based assistive technology interventions effective in improving eye gaze performance over time in children with severe physical impairments? I think that this type of intervention can really open up doors for children who cannot make body movements or speak. It can aid children in controlling mouse cursors onto pictures to communicate what they need to say. So I believe that these interventions could be very beneficial to children in the future. The methods I used for this study were a longitudinal study and the A/B design. They used a Compass computer software where they were able to measure time on task and accuracy with eye selection of targets on screen, and tests were performed with the children at baseline after 5 months, from 9 to 11 months, and after 15 to 20 months. A random effects regression model was then used to identify which factors influence time on task across 4 time periods, which they call T1, T2, T3, and T4. The child was named as a random effect in the model so that correlation between the repeated measurements in each child could be taken into account. The participants for this study were 10 children aged 1 to 15 with severe physical impairments who were beginners to gaze-based assistant technology at baseline. They were referred to by a multi-professional communication team at one regional pediatric center in Sweden during 2010 to 2013. I think that this referral was perfect for this new study. There is a specific type of a population, so convenient sampling was greatly used here. Children were between 1 and 15 years of age, as I said before, and were diagnosed with cerebral palsy, which 9 were, and cerebral spinal cord injury, which one of the children were. They used an aim, task, and compass situation where they were able to use to measure the gaze-based AT performance. It was set up at a standardized environment in the children's school, at their home, and at the pediatric center. The assessment situation was individualized and optimized to support each child to complete the test to the best of their abilities. During these assessments, the children were encouraged to hit the targets as fast as they possibly could on the computer. How it worked was the gaze-based AT was positioned at a distance, and the child was repositioned to have optimal horizontal and height position for eye tracking using the track status viewer. The best user profile was used to improve the gaze collaboration. They used a computer where they could move the cursor with their gaze and select a picture. Results showed that 8 children completed the assessment at all 4 time points, while problems with gaze collaboration caused missing data in the 2 other children. It showed that children with good to excellent improvement in accuracy, and it also showed children who improved in accuracy but not so much, and these were the children with alternating strabismus, and then one child with decreased performance over time because of the treatment regimen epilepsy. Overall, the total number of 1,219 targets were presented to the children, of which 860 were correctly selected, which was 71% of all the targets. So the positive improvements were that 9 children had positive improvements with higher value and accuracy. 7 children had positive improvements with lower values in time on task over time. And then the decreased performance were one child developed a severe form of treatment-resistant epilepsy during the study, and 2 children who improved in performance over time ended with lower accuracy, below 70% than the other children. But overall, these findings indicated that children with severe physical impairments and who were unable to speak were able to improve in eye gaze performance over time. My critique for this study was that the longitudinal study was properly conducted. It was perfect because they needed this time to observe how these children improve their skills during with this new type of technology. This type of convenience sampling worked for the study because it was such a specific type of population. And then conducting a study in children's real environments should be used in order to make performance capacity during gaze-based AT usage in daily life. And then I believe that more individualized tests should be required to accurately test performance in children with other specific impairments. For example, if they can't see or they can't hear. I also think that change in eye gaze may be more variable if there was a larger population or a larger sample, including more children in the study with varying ages, extending the research for a longer time since children need more time to develop and improve these skills. And they also have different learning curves, so some of them may learn faster than others. And the use of parents to rate the children's engagement in the task when measuring eye gaze performance should be used in future studies. So that is my presentation. Please leave your questions in the comments, and thank you so much for listening.